Okay, back to lab number 4, lopes migration. Everybody lopes up. Let's get going. Get your backpacks. Get your what do you call those water pouches?
Oh, an algae.
How about a camel?
Camelback.
Backpack. Yep, you might need it. I've had students go out in a group and like they come back a half an hour after lab's over. It's like, where are you guys? Oh, well, we had to go off campus. It's like, no. Do not leave campus. Everything is within the campus barriers. And in fact, none of the bearings come so close to the close to the fence that you would even think of going outside this campus boundaries. All right, so the whole thing's set up, so everything's done on campus. So if you find yourself going off campus, stop yourself. Do one of those and say, this can't be right. Yeah, you've made a mistake somewhere. The sad thing is you might have to start all over again. All right. But anyway, we'll put a happy face on that because it's kind of funny when you get lost like that. You can imagine what it'd be like if you're in the wilderness, though, going orienteering, like serious backcountry orienteering. All right. So anyway, on your phone, by the way, I'm using my iPhone, so if you don't have an iPhone, someone in your group has an iPhone, so they can at least go there. And then you can figure out what your phone does, how you use your phone for the same kind of measurement. All right, so anyway, settings, compass, you can set true north. All right, so the declination, the magnetic declination, will be removed. All right, so you can see right here it says 0 degrees north and everything's pointing straight up. So that was at my house. Okay, that was at my house. Everything was working perfectly well. We're at an elevation of 1620. It's nice, the campus is nice and flat, so you don't have to take into account changes in elevation. It gets complicated. All right, so anyway, this is what the compass looks like, and it's got that big square in the center because it also doubles as a level. So when you hold your phone, when you hold your compass, you basically want to make sure it's nice and horizontal, and that makes it stay horizontal. So you see if I give it a little tilt, you can see that little crosshair there is not lined up. It doesn't have to be perfect, but that's good right there. Now you'll notice north is pointing off in that direction over there, but true north is like right here. Like I said, there's something wrong with this room. It doesn't even correct with true north in here. So there's something bad in this room. Some kind of poltergeist or something like that. All right, so anyway, you want to set it for true north, and then to make a measurement, you just go like this. You point to true north, 0 degrees, so let's say this is actually correct, and then you touch the little crosshair. And then when you turn, you can, and it'll keep track of the numbers there. So if you wanted to go to like 67, boom. Okay, that's 67. And then the whole time you go, see if you go off track, back, oh, there it is. Okay, it's good to look way off in the distance so that you have a good idea where 67 is, and then you can correct for it along the way so you don't get too far off the right direction. Because it's called propagation of errors. The further you walk, and you're off by a certain amount, the further and further and further you're going off course. Okay. So that's how you make your angle measurements. But I also have compasses in the classroom, and if you're a Boy Scout or a Girl Scout and you've done this kind of thing before, you put red in the shed and then you turn your body. So you can see the shed right there. There's 2 little green lines. And when red is in the shed, then it's pointing due north. Okay, and then your body should be like that, and then you turn to the angle you want to go to. Okay, the only problem here is that it doesn't go the right direction. All right, it goes the opposite direction. All right, so it makes it a little bit more complicated. All right, now what do you do if you need to get around a building? So you can see there's a building right here. And that's where it's good to have a calculator with you, because you can take that bearing and you know what that angle is and figure out what the X and Y coordinates are. And if you got a nice clear path north like this, straight up, you can go up there like that, and then you can walk over like that. Or you could just work around a few buildings, you know. But you know, the campus is pretty much laid out orthogonally, as they say, perpendicularly, but the math word is orthogonal. So the campus is nicely lined up. By the way, when you walk from the security station right here to the Union, that is due north. Okay? So Camelback is east-west, true east-west, and what is it, 35th is true north-south. Okay, now it's good to have a notebook with you, or one of these. We have these here in the room, so you can take that so you got something to write on in case you have to do some calculations. Now you also have to determine your pace, or how far you're going. Now I give you one of these things. This is 30 meters long, but you can see some of those bearings, here I got on the next page, some of those bearings are pretty long, all right? So you can see this 30 meters long, so you need to do 12. 10 times 30 is 300, okay? And then you need a couple more. So you could do that if you wanted to, open it up all the way. But the much better way is to use a program like Argus. Argus actually measures your steps. By the way, one pace is 2 steps. Okay? One pace is 2 steps. So it'll tell you how many steps you've taken. It also if you do like a really good job, but you might be out there for 4 hours doing it because it takes so long to do the tape measure route. But it's so much easier to figure out your pace. So what you can do with this 30 meters, if you did like 30 meters and 30 meters and then walked it out. And when you walk it out, at first you're thinking, oh, I got to worry about how I walk. No, don't worry about how you walk. Just walk like you normally walk, but walk a really, really great distance. And since you know what that distance is, when you get there, it'll average out any little differences in your pace. But you just want to walk naturally. All right, but it's up to you. You decide with your group how you're going to measure your paces. Okay? So that's a couple of different ways. So you could go with a program, or you could just walk it out and do it yourself. All right. So anyway, you get this little PowerPoint so you can see more details if you want to go back in more details. Now, this is what you'll be given. Oops, 1, 2, 3, 4, 5, 6, 7, 8. We got a whole bunch of them that we can hand out. And then you'll use those. We'll give you the map of the campus like this. And when you walk out your bearing, let's say this was your first bearing right here. When you're all done, let's say you get to right here. You put a little dot right there on the map, and then you go do your next one. Now remember, you don't know what your destination is yet. That's the nice thing about doing experimental science. You don't know yet. You're making those measurements, and then you compare with the theoretical expectations. Okay? Do not work out the vectors beforehand. You're defeating the fun of the exercise. Okay, we don't really grade so much on how good your answer is. And especially, when we find out that you worked them all out to begin with. That's lame. So don't do that. You want to actually have some fun, go out there and get this all figured out, end up at your final destination. So remember, everywhere you go, put a little mark on your map, and then you'll be able to connect all those vectors when you go to turn in your lab report. And then make the last vector, the resultant vector, a different color so that it can. You're going to put the theoretical vectors on there with a different color, and be sure and put that resultant vector as well. And then you're going to compare the two. And you can see this is right in front of the Union. So wherever you end up, it'll be some landmark on campus. And you'll be like, oh, this makes good sense. Okay? All right. Let me see. I think that's it. I think that's it. Oh, one last thing. When you get to your final destination on your phone, it tells you what your GPS coordinates are. So you can see right here, gives me my latitude, 33 degrees, 30 minutes, 39 seconds, and my longitude, 112, 751 west. Okay, I need that number. You need to record just the last one. You don't need to record the other ones. Just put a dot on your map, but I want to know where you end up when you get to your destination. Okay, now one last thing. You're going to have to go to the map for the campus on Google. You go to Google Maps, and they will tell you, if you go to this corner right here, Missouri and 35th Avenue, that corner right there, you can right-click on it and go, it says draw a line or something like that. So you go ahead and you mark that point and go all the way over to that little corner right there, and you can figure out what the scale of your map is. And that map that I gave you is the same as this map right here. Okay? So you'll know how to draw your vectors on your map. And then you know when it's in Word and you're working on drawing objects, up in the upper right-hand corner, it tells you and how many inches that way. So you use that to get the X and Y coordinates, and then you can draw your vector out perfectly on your map. Okay, you have to do that for the theoretical values, not for your experimental ones. Those are all done because you'll put little dots on the page. All right, I believe I covered everything. In fact, I've basically done the analysis for you. So your instructor will probably go through that again, but for the most part, you can just come back here and just look at this video again to help you with that. And with that, that's the end of Lab 4, Lopes Migration. I hope you get to your destination. Peace be with you. Over and out.